Hey, welcome back to the basement. I've been asked a couple of times for the source code to some old Stormcloud videos I have up on here. To be honest, I have no idea where I put that code, but what I can tell you is it's old and not very good. So I figured I'd walk you through the basics and then rewrite the code in front of you, kind of code along style. This time around I'm going to do things a little bit differently than I did last time, and hopefully it'll end up better than the original. So let's pull together some supplies for prototyping. First, we're going to need a breadboard for putting the circuit together on. Then we're going to need a microcontroller. Here you can see I'm using an Arduino Nano. Then of course we're going to need some lights. I'll be using a strip of 8 NeoPixels from Adafruit. And finally we're going to need some jumpers to put it all together. There are a lot of different styles and sizes of clouds that you could make, but the most important thing, aside from the lights inside it, is going to be the fact that it needs to look like a cloud. I personally use fiber fill, which is this big bag of what looks like pillow fluff. It's actually pretty cheap. I've built a whole bunch of clouds at this point with it, and I still have 85% of this bag left. I also suggest using a spray adhesive to hold this stuff down, something like Super 77. Alright, let's build this prototype real quick. First we'll plug in the Arduino Nano, then we'll hook up our NeoPixel strip. This particular strip has 2 ground pins for some reason, so we gotta make sure that we hook both of those up. Also, I'm gonna plug the 5 volts on this into VIN and not the 5 volt pin on the Arduino. The big difference here is that VIN is gonna be whatever the raw power supplied to the Arduino is. Sometimes that's more than 5 volts, so you have to be careful, but in this case I know that it's gonna be 5 volt USB. So that's going to work just fine. The benefit over the 5 volt pin, of course, is that the 5 volt pin runs through the voltage regulator, and if you were powering a lot of NeoPixels, you would burn that out. And finally, I'm going to connect the D-in pin to D5 on the Arduino. Before we start writing any code, let's talk about how we're going to manage the animation in the NeoPixels. You could manage the movement of a bunch of variables by hand, keeping them inside of some limits and offsetting their animation speeds and things to kind of get the effects you're looking for. I used to do that a lot, and sometimes you'll still see me do that, but for this I'm going to go a different route, and I'm actually going to try to use some math to get it done. While the math can be a little hard to follow at first, it's actually more predictable and requires a lot less code. To do that, we're going to leverage a sine wave. Sine waves are awesome because they oscillate between -1 and 1. So all we have to do is a little math to get that to oscillate between the 2 values we actually want. The iteration variable here is just simulating the Arduino's millis call, which returns the amount of milliseconds that have passed. So the first thing we want to do is make sure all of the values are positive. So we'll add 1 to this. That will make the values go from 0 to 2 instead. This is running a little faster than I'd like, so I'm also going to divide the iteration by something to slow it down. Because we want our cloud to be mostly blue all the time, I'm going to put a floor of 90 on it by adding 90 to it and reducing what we multiply the sine wave by. That will give us a blue value that oscillates between 90 and about 250, which should look nice. This next step isn't really necessary, but just to show off the power of using math for this, I'm going to grab the sine value to the power of 3. That'll make the movement a little more interesting. Alright, so now we have blue looking good, but we also have red and green in these NeoPixels, so we might as well use them. For red, I'm going to start with the same exact setup I had for blue, but I'm going to reduce the 100 to 40 so there's less red. I'm also going to slow it down a little bit to make sure this pattern takes longer to repeat. Hopefully you can see how easy it would be to speed up or slow down one of these colors, or make small alterations. Finally, for green, I'm going to start from the same values as red. But I don't want the waves to line up exactly, so I'm going to shift the green wave forward a bit. Actually, why don't we get the power of something just like we did on blue to make this a little more interesting? Here I'll get this value to the power of 4. That does reduce the peaks a lot, so I'll bump them up a little bit by multiplying them by 50 instead. And I'm going to reduce the speed on this by a lot, so it takes a really long time for the colored patterns to repeat. Let's just take a second and get a sense for how these colors shift around and what the product is going to look like. We'll come back to those values in a minute, but first we need to lay down the basic code to interact with a NeoPixel strip. This is basic stuff, so I'm going to run through it, but you're welcome to look at the code to get a sense for what's going on here later. Perfect. I'm going to lay something on top of this to diffuse the light a little, that way we can see the colors better later. It's a little bright, so I'm also going to add a setting for adjusting the brightness. Okay, that looks good. Now let's work on getting our first formula written in JavaScript ported over to C. For this, we'll make separate variables for the red, green, and blue values. Then we'll punch in the formula for red. There's not a whole lot of difference here, except you have to be explicit about your numbers being floats, so I added a 0.0 to the end. And you also have to cast the result of this formula back into a byte, because that's what we're storing in our variable. The math functions are pretty much all the same, except they're not preceded by math dot. You can see I also reduced the milli value just to slow it down a little more. Okay, let's do the green formula now. Alright, that seems like it's working the way we'd expect. Now let's do blue. Alright, that's all of them. Now you might ask yourself, why do these colors look a little different than they did in JavaScript? Are the values the same? So the thing you should know about NeoPixels is that the colors are not really accurate. You could put a little more work into getting them closer, but generally they're not going to match exactly. For our storm cloud, that's totally fine. Just to be sure that the formulas aren't way off, let's set up some serial communication so that we can get a graph back of what all the colors are doing. I'm also going to consolidate the milli reduction, just to make it easier to adjust later. You'll see here that I'm sending back the R, G, and B values, separated by commas with a line feed at the end. When numerical data is sent back over serial like this, you can graph them on a chart instead of having to look at them in plain text. As you can see, the values coming back look just like the JavaScript graph we had earlier. So perfect. Now let's get the colors running across the whole strip instead of just one pixel. Awesome. So now that we have the basics down, you could stop here, but I think it would look better if the colors slid across the strip instead of changing the whole strip at the same time. So let's do that next. This is actually pretty trivial. The basic idea here is we want to put a distance between the color of each neopixel. Because we derive the color of each neopixel based on the amount of time elapsed, all we have to do is bump that value up depending on the index of the neopixel we're setting. We'll multiply it by some arbitrary number for now, call it 400, and that'll be the difference in color between pixels. You'll notice I'm making a single variable to store the elapsed time. I also made a variable for the LED index, and I'm going to make sure that that loops. Finally, I'm going to make sure we only send back the values for the first neopixel. That way our serial display doesn't look crazy. Actually, let's take that 400, make it a setting instead, and increase it to 650. Also, we have to remember to remove the for loop, and only set the neopixel based on the index that we're on. Let's have a look at that. Oh, there we go. That looks awesome. Now to me, a good storm cloud also needs some random lightning. So let's talk about how I do that. I'm going to start with our original formula, but take the red and green values and line them up. Then I'll make them a lot faster and raise their peaks a lot. That way, when they're high, the color will be more like a white. And then we can even vary the speed of this to give the lightning kind of a random feel. Now that we have the formulas figured out, let's break the display into two pieces. One mode with lightning and one mode without. First, let's make some settings so we can fine-tune this later. We'll make one for the maximum brightness of the lightning, what the chance of the lightning happening is, how long the lightning lasts for, and even the frequency of the lightning. As the normal display mode runs, there'll always be a chance of switching to lightning instead. I don't want this to happen too often, so I'm also going to use a variable to keep some padding between the last strike and the next. When we switch modes, we'll generate a random frequency for how fast it blinks, and a random amount of time it should go for. Now let's set up the lightning with those formulas we just made. The blue formula is exactly the same, so we're only changing the red and green. It looks like I forgot to make the setting for the amount of time between lightning strikes, so let's do that real quick too. Alright, that looks perfect. It is a little obnoxious. Of course, you could tweak your settings to make this happen less, or make it less intense. I would suggest adding a button or a switch or something so you can actually turn off the lightning. I've also made settings that will switch the cloud to be full white, that way it's a little more useful as kind of a lamp or a light. Of course, this looks a lot nicer in the pillow fluff to actually turn it into a cloud. I'm not making a full cloud myself, but I will show you what that looks like. The key is just making sure that your lights are completely enclosed inside the fluff. If you're making a bigger cloud, you want to make sure your lights are wrapped around something, like a paper towel roll. And any gaps you have, or anywhere that looks a little bit sparse, you could just hit with spray adhesive and press more fluff into the side. So that's really all there is to making something like this. I'm impressed you made it to the end of this video. I know it was pretty dry material, but hopefully you learned something, and I'll add some comments to the source code to kind of clarify things a little better. And if you have any problems or you do end up making something like this, give me a comment below. I'd love to hear about it.